All right, hi folks.
Hello.
Byron Messino here. Folks, we'll get started in a couple of minutes.
Hello. Hello.
Folks, also let me know if you have any questions as we're waiting.
Hello.
All right, folks, let me know if you have any questions as we're waiting. We're going to get started in just a couple of minutes. All right, folks, why don't we get started? Folks, here's the calendar. So please notice today we're going to review chapter 10. So this is a practice test that we'll go over for chapter 10. Before I do that, I want to go back. I think there was one problem left in section 10.8. So let's do that.
So next week is all week of reviewing for final exam then.
Practice final exam. So there's a
Wait.
practice final exam posted in Canvas. And
plus like for the final exam, like the questions will be like similar then.
And folks, let me mention to you about the actual final exam. So,
I mean, the problems will be similar then.
summary for the actual final exam. This is posted in Canvas. I'll talk more about this next week, but I just want to point out to you folks that our final exam is Monday, May 4th at 10 a.m. So please mark that on your calendar.
So
in WebAssign, but we're going to use Zoom as a remote proctoring. Okay, so I'll go over this more next week, but for right now, please just make sure that you are going to set aside Monday, May 4th at 10 a.m. If you have a conflict, please let me know that so we can figure out some other options. Okay? Folks, a reminder, the WebAssign activities are open until May 1st, but please try to catch up as much as possible and try to get current, if you can, with the WebAssign homeworks.
Wait,
Right.
so the questions will be similar then, the questions.
Or what's coming up over the next week or so. All right, hang in there. We're almost done. We have about a little more than a week left to finish up the course. Okay. All right. Folks, let me go back to section 10.8 so that we can finish that up. Now, I did want to mention, let me go to section 10.8. I had a few questions from students about how to enter answers in WebAssign for section 10.8. So a few students were getting questions marked wrong, and it was only because they were not entering the answers the way WebAssign wanted. So I added a slide. Let me bring up this PowerPoint and I'll show you what I mean. Let me go to a slide on how to enter answers in WebAssign. Okay. So, jumping down to a slide. Yeah, here's slide 18. And so I wanted to show you that when you're entering an answer like the vector 3, 4 with the angle brackets, or maybe you're entering an answer like 6i plus 4j, let's say. So if you're entering an answer like 6i plus 4j, or maybe you're entering an answer like 6, 4 in angle brackets. Here's the math menu in WebAssign. And notice I'm coming down here to this vectors option. When you click on vectors, you get this menu that shows up. So if I wanted to enter 6, 4, I'd be using this icon, right? Click here, and it will let you enter a vector in the angle brackets. What if I want to enter 6i plus 4j? Remember, you can't use the I and J characters from your keyboard because I and J are vectors. That's why you see them in bold in the slides here. So what you have to do is type in 6 and then come over here and click on this menu item, which would be I in bolded, boldface, right? That's telling WebAssign that you're using the vector I, not the letter I. And then if you wanted to enter 4J, you would come over here and click on this letter J, and WebAssign would enter it in bold. Okay? So use this math menu when you're entering answers here for section 10.8. So WebAssign is happy with your answers. All right, folks, any questions on this?
So for the final exam, so the questions will be similar, the one from the practice exam.
So we were talking here about finding unit vectors. So let me draw this vector that they're giving us. So they're giving us this vector here of 3i plus 4j. Okay. Well, this vector, imagine going over 3i. Remember, I is the unit vector in the x direction, and j is the unit vector in the y direction. So I could go horizontally 3 and vertically 4. This would be 4j. The vector that we're talking about here would be this blue vector that looks like this. Okay, so this vector is vector A. But they're asking me to find a unit vector. What they're really asking me then is find a vector that's in the same direction as A, but is only length 1. So that would be this purple vector here. So this purple vector is the unit vector that they're asking you to find. All right, so how do I find this? Well, first, I'm going to find the magnitude of this vector. The magnitude is where you just take the square root of 3 squared plus 4 squared in my example. Really what I'm doing when I find the magnitude is I'm finding the hypotenuse of this right triangle. So in our example, the magnitude of vector A, I would write it as these vertical bars A. It would be the square root in our example of 3 squared plus 4 squared. Right? Because in our example, our vector was 3i plus 4j. So in our notation here, A is matching up to 3 and B is matching up to 4. So when I plug A in here, it's going to be 3 squared. When I plug in B here, it's 4 squared. So this is just going to be the square root of 9 plus 16, square root of 25, which is 5. So, this is just a right triangle that had one length 3, one length 4, and this hypotenuse was length 5. All right, so that's the magnitude part. But now it says if you want to calculate the unit vector, set up this fraction where you take the original vector on top. So this is the starting vector on top and the magnitude on the bottom. So let's do that for our example. Our example will be taking vector A and divide it by the magnitude of A. All right, well, our vector A was 3i plus 4j to start with. Our magnitude was 5. So this is the unit vector. Usually we break this up into 2 separate fractions. You don't have to, but this is typically the way you write. So it'd be 3i over 5 plus 4j over 5. So this is the answer that WebAssign is looking for. But
plus, when you use the letters between 3i and 4j, like you have to use the vector version.
Okay, taken from that vector menu that pops up on the right-hand side. Okay, and as a double check, if you were to find the magnitude of this, so this is the unit vector here. If you were to find the magnitude of this vector, it would have to be magnitude 1. Because that's the definition of a unit vector. It's length 1, magnitude 1. If you found the magnitude of this vector and it wasn't magnitude 1, that means you must have made a mistake somewhere. Okay? Folks, any questions on this example? And you might remember that we worked through this example on the previous slide. So if you want to see a worked out example here, you can kind of follow along with this. In this case, the vector was negative 5i plus 12j. Right? So remember, if we write the vector in angle brackets like this, it's really the same as writing it using the ij notation. All right, folks, if there's no questions on 10.8, I will go ahead and get into the practice test for chapter 10. Okay, so here's the practice test. And I'm going to also bring up the chapter
Well,
summary side by side so that we can use that as a reference too. All right, folks, let's try to do one type of problem from each of the
hello.
variety of problems here. I don't think we'll have time to do every single problem. So why don't we try to do one problem from each concept? All right, folks, it turns out that problems 1, 2, and 3 here are based on law of cosines. So these problems are law of cosines. So let's do one of these. If anyone has a preference on whether to do problem 1, 2, or 3 here, let me know. They're all going to be very similar in the way we set it up. Okay. Why don't we do problem number 2, for example? Because problem number 2, we have to draw our own diagram. So let's do problem number 2. Remember, first step is you must draw a diagram. So let me draw a diagram.
We're doing number 2.
And you can label the diagram any way you want. I'm going to label it as A, B, and C. But you can label it however you want. I'm noticing they're telling me angle B is 82 degrees. So I know this angle is 82 degrees. They're telling me side A is 2.2. Remember, I have to put side A opposite angle A. And they're telling me side C is 9.7. All right, so I drew a diagram. Now, when they say solve the triangle, what they're really asking me to do is find the unknown sides. So side B is unknown, angle A is unknown, and angle C is unknown. So I have 3 unknown quantities to try to figure out here. All right, well, let me try to use law of sines and see if it helps. So I'm going to come over here to law of sines. Remember, you can either use this top format or the bottom format. We've been using this bottom format, so I'm going to use the bottom format. What I'm going to do here is circle what they've given me. So they've given me side A, they've given me side C, and they've given me angle B. Well, notice I cannot use law of sines. Why not? Well, the reason is I would need to have 3 out of 4 quantities available to set up an equation. But if, for example, if I look at this equation right here, right, if I look at A over sine A equals B over sine B, all I know is side A and angle B. So I don't know 3 out of the 4 quantities here. I only know 2 out of 4. So that's why this is no good. We cannot use law of sines. So let me go to law of cosines. And let me try to figure out which one of these options I should use here. Should I use equation 1, 2, or 3? Well, in our example, we're given angle B. So if I'm given angle B, this is the only equation here that has angle B present. So I'm going to use this setup because this is going to let me find side B. So this is our equation to use here. Does that make sense how we kind of got to this equation? We tried law of sines, but law of sines was no good. So we went to law of cosines and we said we have angle B, and this is the only equation that includes angle B. All right, so let's write it. It's B squared equals A squared plus C squared minus 2 times AC cosine B. All right, so let's fill it in. In our example, it's going to be 2.2 squared plus 9.7 squared minus 2 times 2.2, 9.7 cosine 82 degrees. Now remember, folks, this is a job for your calculator. So type in this entire right side into your calculator at one time, right? Don't do these calculations separately. Type this entire right side into your calculator and let your calculator do the work. So I'm going to do this myself. And when I do this myself, I'm getting the answer of 92.990. Okay, double check me on this. Make sure that if you try this yourself, you get the same answer. That's b squared, but I want b, so let me take the square root of 92.990. Notice the way I'm carrying out my answer to 3 decimal places, or even 4 decimal places. I'm going to carry that to 3 decimal places, just to be on the safe side. Because I know the problem says round to the nearest 10th. But I don't want to round intermediate calculations to the nearest 10th. I only want to round my final answer to the nearest 10th. So when I work this out, I'm getting the answer 9.643. But of course, they said round to the nearest 10th, so 9.6 is the answer I'm looking for side B. All right, so we found that side B is 9.6. All right, but I still have to find angle A and angle C. Well, here's the good news. I can now use law of sines. Because if I go back to law of sines now, I know this side, B. So that's going to let me solve for angle A. So let me go ahead and do that. Now we can use law of sines. So let me do it over here. Try to get rid of some of this to make some room. Okay. I love that eraser. That eraser is very nice. All right, so we're going to use this formula. A sine A equals B sine B, because now we do know 3 out of 4 quantities. So let me plug in. Side A was 2.2. Angle A is unknown. Side B we just figured out is 9.6 over sine of 82 degrees.
We usually just do a sine A over
The
A.
way to do this now is cross multiply. So let me cross multiply. This is going to be 9.6 sine A equals 2.2 sine 82 degrees. All right, but I want to get sine A by itself, so I'm going to divide both sides by 9.6. So that leaves me with sine A equals, and again, I'm going to work this out on my calculator. So let me work that out on my calculator. Then I'm going to do this all at one time. And I'm getting the decimal answer 0.22693. But one last step, I need to find angle A. So what I'm going to do is take the inverse sine of both sides. Remember, I want to get A by itself. I want to know what's angle A. So I really want to eliminate or cancel out the sine function. So to do that, what we do is we take the inverse sine of both sides. Well, inverse sine and sine are inverses, so they cancel out. So I'm ending up with A equals, and now this is a job for my calculator. When I go to take the inverse sine, I'm getting 13.116 degrees. But they wanted this rounded to the nearest 10th, so it looks like our answer is going to be 13.1 degrees. All right, so angle A is 13.1. One last item is we need to find angle C. But that's actually going to be pretty easy because I know that the three angles in any triangle have to add up to 180. So to find angle C, I'll just take 180 minus angle A, which is 13.1 degrees, minus angle B, which was 82 degrees. And this should let me figure out angle C. And if I work this out on my calculator, I'm getting the answer that angle C should be 84.9 degrees. All right, so folks, this is a bit of a messy problem because you had to find three unknown quantities here. We had to find side B, and then angle A and angle C. This problem ended up being law of cosines because we really didn't have enough information to use law of sines to begin with. But once we found side B using law of cosines, we could then go back and use law of sines to find the other missing angles. All right, folks, any questions on this example? All right, well, why don't we go ahead then and look at problems 4, 5, or 6. Now, these problems are law of sines. Oh, folks, Gennaro, I think I wasn't hearing you. Hold on a second, folks.
Oh, I asked a lot of questions I asked.
Gennaro, I'm not hearing you.
I mean, I have my microphone on.
Make sure my speakers are working.
My speaker is working.
I do have my speakers on.
Well, my mind's working.
Can you hear me?
Try this. Gennaro, can you speak so I can see if I can hear you now?
Hello?
Yes, Gennaro, now I can hear you. But
Yep.
Can you hear me okay?
Yeah,
Okay, good. I apologize.
it's fine.
Okay. Gennaro, can you repeat your question?
I mean, for the final exam, like the questions will be similar from the practice final exam then.
Exactly right. Yeah. For the final exam, the problems will be similar to the practice final. Exactly. So next week,
Like,
when we
so
go,
we have to study for the homeworks then?
yep. So next week, we're going to go over the practice final exam. If you can understand the problems on the practice final, you're going to be well prepared for the actual final.
So do we also have to go back to the previous homework to study as well?
Yeah, it's a good idea to go back to the previous homeworks. And Gennaro, I think what you're going to see next week is that the practice final questions are really identical to the homework questions.
Just like the same thing then.
Same problems. Yeah, exactly right.
I already took the chapter 10 test.
Good, excellent. Folks, please try to take the chapter 10 test, soon, by next week,
Wednesday.
early next week maybe. This way you give yourself enough time to prepare for the final exam.
I took my test on Wednesday.
Yeah, great job. Good, thank you, Gennaro. All right, folks, why don't we look at either 4, 5, or 6 here, because these are all going to be law of sines problems. So these are all similar for law of sines. Okay, why don't we do number 6, because this one is just a little different than the others. Well, for problem 6, they actually gave us a diagram, which is kind of nice. And how about if I label the diagram? I'm going to label this as angles A, B, and C. Remember, you don't have to label a triangle the way I did. You can label it as angle A, B, and C, any angles you want, but you have to then label the sides.
Oh, so we're doing question number 6 we're doing?
Let's do question 6, yeah.
Okay.
All right. So they really want me to find side A in this example. I know they said find side X to begin with, but I labeled that as side A just to match up with my labeling scheme. All right, can I use law of sines for this one? Well, here's one thing I'm noticing. They've given me two angles.
You have to use the law of cosines for that one.
Well, let me see if I could use law of sines, because usually law of sines is a little easier to work with.
Yep.
So if I could use law of sines, I would like to do that. So let me give it a try. One thing I'm noticing here is they've given me two angles. Well, if you know two angles in a triangle, you can automatically figure out the third angle. Right, so angle C, I'm going to figure out by just taking 180 minus 24 minus 120. All right, so it's always a good idea if you know two angles to just quickly calculate the third angle.
You have to do 180 plus 24.
Well, Gennaro, I'm subtracting these angles. I could do it another way. I could take 180 minus the sum of the other two angles. Maybe let's do it this way. So if I add up the other two angles, right, they add up to 144. Well, that tells me that angle C is 36 degrees. Right, I'm taking 180 minus 144 degrees. 144 is the sum of the other two angles. So I know angle C here is 36 degrees.
Now we can use the law of sines now.
Let's use law of sines because I think it's going to be easier. Let me circle what we're given. We know angle A, B, and C.
We have to find angle B. We have to find.
Okay. Well, Gennaro, they gave us angle B as 120 degrees, though.
No, I mean like we have to find B. We have to find.
Yeah. Now, Gennaro, the way I labeled my diagram, I put angle A up here. Remember, you don't have to do it this way. Because I put angle A up here, the opposite side is side A, and that's what they were calling X here. So the way I drew my triangle, I'm interested to find side A. Okay, well, I also know side C, right? Now remember, side A in my triangle is unknown. So I can take this first fraction and set it equal to the third fraction. I'm going to do that over here. I'm going to set the first fraction A over sine A equals C over sine C. The reason I'm doing it this way is I know side C because they gave that to me in the diagram. All right. Folks, remember, you might be setting it up a little differently if you labeled your triangle in a different way than I did. And it's perfectly okay. You'll get the same answer. It's just that I happen to label the triangle this way. All right, so let's go plug in now.
I got 14.7 for B.
So we know angle A is 24 degrees. We know side C was given to us as 10. And we calculated angle C as 36 degrees. All right, now I'm going to cross multiply. So this is going to be A times sine 36 degrees equals 10 times sine 24. I want to get A by itself, so I'm going to divide both sides by sine 36 degrees.
I did sine B over B, then equals sine C over C.
Yep, Gennaro, that would be equivalent and equally correct based on the way you set up your triangle.
Yep.
All right, let me work this out now. Remember, do this all at once on your calculator, right? Type in this fraction all at one time on your calculator. And when I do that, I'm ending up with the answer 6.9198. But I could see the instructions say round to the nearest tenth. So my answer is going to be 6.9. Right? By the way, do it, folks, remember to do a quick sanity check on your answer. Right? I know if this side is 10, if I came up with an answer like, you know, somehow if my answer turned out to be 697.3, well, that looks totally unreasonable for this triangle, right? So I would know if I came up with a weird answer like that, it really doesn't seem to make sense when the other side of the triangle was 10. Right, folks, any questions on this one? So this was an example of using law of sines, because we were able in this example to plug in for angle A, side C, and angle C, and that meant A was the only unknown quantity, and we cross multiplied and solved for A. Okay. All right. Folks, by the way, don't worry about copying down information here because this is recorded. So you can go back and watch the recording later if you didn't get a chance to copy down. All right, folks, let's do a few more examples here. By the way, folks, if we don't finish today, we could do more of these practice questions on Monday as well. But let's keep going. Let me go to number 7. Number 7 says, find the area of the triangle. Now, for this triangle, I can't use the formula that you remember from geometry that said the area of a triangle is 1/2 base times height. Because when you use this formula, you need to know the vertical height of the triangle, which is this height right here. So this would be H. And this side would be B, let's say. But I don't know B and I don't know H. I could calculate them, but it would be kind of messy to try to calculate. So I'm not going to use this formula. Instead, let me go over to the chapter 10 summary, and I'm going to come down to these notes here. It says, if you want to know the area of an oblique triangle, remember, oblique means a non-right triangle. And I know this is a non-right triangle, right? Because there's no right angle. So I'm going to use this formula, or one of these formulas. Now, before I do that, let me label this triangle so I can decide which format to use. All right, and again, it's up to you to label this any way you want. So I'm going to label this, let's say, as angle A, angle B, and angle C.
For that one, I put angle A on top, then B on the corner, and the C on the other corner.
Okay. Janara, let me label it your way, because it doesn't matter. So Janara, say again, you label the top as A.
Yep. A on top, B on the left corner.
B on the left corner, and C down here.
Yeah.
Okay. Perfectly okay. Remember, you can label these any way you want. Well, that means this side is side A, this side is side B, and this side is side C. All right. So it looks like I know, here's what's given to me in this example. What's given to me is angle A, side B, and side C. So I'm looking for a formula that involves those three quantities. Well, you might notice this formula right here involves angle A and sides B and C. So let's use that formula because that matches our diagram. All right, so now this is just a simple matter of plugging in. Side B is 15, side C is 24, and then angle A is 30 degrees.
And I get the answer of 90.
So I could do this on my calculator, or because I know sine of 30 degrees is 1/2, I could just plug in 1/2 here. And if you work this out, this is going to be 15 times 24 over 4. But I know 24 over 4 is 6. I'm just doing this in my head. So 15 times 6. It looks like this area is going to be 90. Okay, and remember, this is square units. So This might be, for example, square feet, the unit square feet. But the answer here is 90. Okay, folks, so all we had to do for this problem was grab the correct formula from the chapter 10 summary. All right, folks, let's move on to polar type discussions. All right, so here it says, convert this equation to polar. So I'm going to convert to polar, okay? Well, let me come over here, and it says if you want to convert from rectangular to polar, I can use these formulas here. All right, so let me write down the equation they're giving us. They're giving us x squared plus y squared equals 4y. Remember, my answer can only have r and theta in it, right? I have to get rid of x's and y's. All right, so let me try to do some substitutions. Well, let me look over at the left-hand side here. I'm noticing it's x squared plus y squared. But here's a formula that says if you have x squared plus y squared, you can replace it with r squared. So I'm going to replace this with r squared. Let me come over to the right side. I have a letter y, but I have to get rid of y. Here's another formula that says y is r times sine theta. So I can replace this y with r sine theta.
Then you have to divide it.
Yeah, because I can do a little bit of cleanup because I'm noticing I could divide both sides by r. That will cancel this r out, and I'm ending up with r equals 4. So that's the answer to this question. And I know I'm done because notice there's no x's and y's anymore. Right, I got rid of x's and y's and replaced it with r's and thetas. Okay. All right, folks. How about if we do number 9? I want to do number 9 because it's a little trickier. So let me go to number 9. It says r equals 6 over sine theta plus 5 cosine theta. Now, this is the other way around. It wants me to take a polar equation and go to Cartesian. Remember what Cartesian means? They want just x's and y's in the final answer.
I mean,
So
plus
my
you have
answer
to
here
mx plus b form has to be.
my answer can only be with x's and y's in it.
Like when I got the answer right, it's like an mx plus b form. Y equals mx plus b.
It could be in y equal mx plus b form, but it doesn't necessarily have to be that way.
Yeah.
All WebAssign is asking you to do is get rid of the r and theta variables, and your equation should only have x's and y's. All right, well, I need to do some substitutions here. Let me take a look here. I'm seeing a sine theta. How can I get rid of sine theta? Well, I'm noticing here's a sine theta. So how about if I divide both sides of this equation by r in order to get sine theta by itself? So if I do that, sine theta equals y over r. Let me do the same thing up here while I'm at it. Let me divide both sides of this by r. So then cosine theta is x over r. Now let me go do some substitutions. On the bottom for sine theta, I'm going to put y over r. And for cosine theta, I'm going to put x over r. Of course, I'm still not done because I've got to get rid of the r's. Remember, my answer can only have x's and y's. Well, here's a little trick I can use now. What I could do is put r over 1, because I want to make this look like one fraction equal to another. Now I'm going to do the old cross multiplying. method. Remember, when you have one fraction equal to another fraction, you're allowed to cross multiply this way. All right, let me do it. So I'm going to take r times this bottom part here. So that's going to be r times y over r plus 5x over r. And then I'm going to multiply the other direction, which is 1 times 6, which is just 6. But now I'm going to let this r multiply inside the parentheses. So it's going to be r times y over r plus r times 5x over r equals 6. And of course, now I can see the r's cancel out. This r on top cancels out with the r on the bottom. This r cancels out with that r. So it looks like I'm just left with y plus 5x equals 6.
I mean, if you subtract the 5, then it's going to be like a y equals mx plus b form.
Yeah, you could, Gennaro, if you want, write it as y equals negative 5x plus 6. But you don't have to write it that way. It's up to you. So either one of these two answers would be equally correct. But notice my answers only have x's and y's in them. They don't have any r's or thetas anymore. All right, folks, why don't we go to a few more examples here? Again, we could do more of these on Monday, but how about if we go to number 12 or 13? These are similar on graphing polar equations. All right, so let me scroll down to my polar graphs. Here they are. Okay. So what I want to do as the first step, you might remember, is match up the equation. Let's do number 12. Why don't we do number 12 here, let's say. So let's do number 12. So I want to take the equation they're giving me and match it up to one of these choices. Okay. Well, I'm noticing my equation could match up to any of these options here. So let me write it using A and B the way they're doing it. So this would be A minus B sine theta. When I do that, I notice RA matches up to 2 and RB matches up to 2. Well, let me check out A over B because that's part of the criteria that I'm seeing. A over B is equal to 1 in this example, right? Because our A over B is 2 over 2, which is equal to 1. Well, that means our equation is really matching up to a cardioid. So our equation is a cardioid. Now remember, when you go to do this in WebAssign, it's going to show you 4 graphs. And you're going to have to pick the correct graph out of the 4 choices. So now that I know it's a cardioid, what I do is I scroll down and look at the more detailed picture of cardioids, which is here. Okay, so let me try to take a look at this, these options and match it up to my example now. Okay, remember our equation is R equals 2 minus 2 sine theta. Well, I know choice A is out because choice A involves cosine theta. Same for choice B, involves cosine theta. Choice C is out because choice C has a plus sign, right? It's A plus B sine theta. But our equation is 2 minus 2 sine theta. So that means our graph is graph D, which means it's a cardioid on the bottom of the polar graph paper. So I need a cardioid that looks like this, where the cardioid is oriented on the bottom. So if I go and take a look at the answer choices, let me jump down to the answers. Here it is. Notice it's a cardioid that's on the bottom of the graph. Okay. Folks, remember, you're not going to be graphing these equations by hand. Instead, you're just going to be picking which graph out of 4 choices is the correct one. Okay. All right, folks, why don't we come down here and do 1 or 2 more examples. I think we just did a unit vector example at the beginning of class today. So why don't we look at number 15? Let's look at number 15 here. So they're asking us to find the vector 5v plus 3u. Okay, I know vector v, it's given to us, and I know vector u, it's given to us. And you know, really this is going to turn out to be more of an algebra type problem. So what I'm going to do is take the scalar 5 and multiply it times vector v. The vector v was given to us as negative 4i minus 7j. And then I'm going to take the scalar 3 and let it multiply vector u. The vector u was I plus 8j. Well, remember that when you have a scalar, you can almost think of it as like multiplying using a distributive property. So this is going to be negative 20i minus 35j plus, I'm going to let the 3 multiply in the parentheses, 3i plus 24j.
Negative 17i.
Yep.
Negative 11j.
You got it, right? So the last step is really just combining like terms. Let me combine together negative 20i with plus 3i. So of course those combine to give me negative 17i. And then I'm going to combine the j components. That's negative 35j combined with plus 24j. That's minus 11j. Okay. Folks, remember that you have to go into the math menu and select those buttons for I and J when you enter your answer, right? Folks, and if you forget to do that, you know, if you end up with a problem marked wrong because you forgot to enter your answer in this vector format, please email me and let me know that, and I can go in and give you credit. So I don't want you to lose points just because you didn't enter your answer quite the way WebAssign wanted you to. Okay, folks, I think we have 1 or 2 minutes left. Why don't we do this last example here for a unit vector? Okay, so for a unit vector, remember the way you do it is you take the starting vector and divide by its magnitude. Okay, so let's find the magnitude of this vector first. For the magnitude, it's defined as the square root of a squared plus b squared, where a is this number. I'm going to change this. I don't want to confuse things. It's just going to be the square root of 20 squared, right? Because that's the coefficient of I, plus 21 squared, that's the coefficient of j. And if you want to, you can make your own little right triangle up, right? Because if I was to think about this right triangle, this would be the I direction 20. This would be the j direction 21. So we're finding the length of this hypotenuse. And really it's Pythagorean theorem. So let me work this out on my calculator.
29.
20 squared is 400. 21 squared is 441.
29 you get.
Yeah, so if you work this out, you get 29. Okay, so that's the magnitude of A. Now to find the unit vector, all we have to do is plug in to that formula. Let me erase this so we can type it in here. So now I'm just going to write the answer of A over its magnitude by writing the original vector, which was 20i plus 21j, over the magnitude that we just figured out was 29. Sometimes you can break this up into 2 fractions. You don't have to, but If I was to break it up into two fractions, it'd be 20I over 29 plus 21J over 29.
That's what I got.
Good. All right, folks, I think we're out of time. Any questions on any of these examples? Folks, please try these yourself. If you have any questions, you can email me, or we can do more of these examples on Monday. And then Monday, we'll also get started on the practice final exam as well.
I thought we were only just doing final exam for a review.
Yeah, we'll do a final exam review next week, Gennaro.
Yep.
But if anyone has any other questions, please feel free to bring those up on Monday. We can answer those questions as well. All right, folks, if you have no questions, feel free to log off. Thanks for joining today.
So there'll be 20 questions on the final exam then.
Exactly right, Gennaro. Yes, 20 questions on the final exam.
We have like 2.5 hours to take it.
Exactly. Yep.
All right.
Folks, I'm going to hang out for just a minute in case anyone has questions. Otherwise, have a good weekend and hope to see you on Monday. All right, folks, if there's no questions, I will close out. Again, thanks for joining today.